Hey guys, this is a way for us to take a look at all the stuff we've done so far this year. And what we're looking at now is a unit that's on linear type stuff. That includes some absolute value, that includes some systems of equations, and solving equations and inequalities all kinds of different ways. Here we're looking at one of our lovely complex equations. It has lots of fractions going on. First thing I might do is to try to simplify some of the stuff here. In particular, I might do that distribution before I do anything else, and then I'll worry about dealing with the fractions. So in setting that up, we've got negative 7 over 2 times negative 5 over 3, which is going to be 35 on top and 6 on the bottom, n. And then we've got negative 7 over 2 times positive 3 over 2, which would be minus 21 over 4. Here we've got n minus 131 over 36. If I don't love these fractions, one of the things that I could do would be to multiply this entire equation by 36. And that's not a necessary thing for me to do, but that could be a helpful step in terms of making some sense of this. So we'd end up with 36n negative 131 times 36 over 36. Those cancel. I end up with negative 131. 36 times 35 over 6. The 6 would cancel with 36, and then we'd be left with 6 times 35n. And then we've got 36 times 21 over 4. And that would end up being 36 divided by 4 is 9. 9 times 21. Okay, let's do some simplifying. 36n minus 131, that stays the same. 6 times 35 is going to be 180. It's going to turn into 210. And then we've got 9 times 21, which would be negative 180, negative 189. Okay. Let's combine some like terms. By the way, that should have an n. If I minus 36n from both sides, we end up at 170, 180, and then minus 6 more is 174. And if I add 189 to both sides, 189 plus negative 131 is going to be 68. When I divide both sides by 174, we get n is equal to 1 over 3. After you reduce 68 over 134 or 174. Next up, we've got an inequality. First thing I'm going to do is do some distribution, and then I'm going to get everything onto one side. So we get negative 2 times 7b is going to be negative 14b. And then minus 8 minus 1 greater than or equal to. Distribute the negative 6b and distribute again. Plus 48 minus 8b. Okay, I'm going to bring all the b's onto the left side, so I'm going to add 6b and add 8b, which is really plus 14b and plus 14b. Oh, that's interesting. So we get 0, okay, minus 8 minus 1 is minus 9, and on the right side we've got 48. So this tells us that negative 9 is greater than or equal to 48, which we know is not true. This in fact has no solution. We found a not true statement, which means it has no solution. Sketching the graph of this line, I could do this in one of two ways. One would be to put this into y equals mx plus b, and the other is to make a table. I'm kind of, based on the numbers here, I know that 20 and 4 divide nicely. I'll probably get the y by itself. I'm going to add 4y to get to this side and add 9x to get to this side. We end up with 4y is equal to 9x minus 20. When I divide both sides by 4, I get y is equal to 9 over 4 x minus 5. I was about to write minus 20 again. So minus 5, and we're going up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And 4 to the right. 1, 2, 3, 4. If I wanted to identify that x-intercept, I plug in 0 for y, and we get 9 over 4x minus 5. We end up with 5 is equal to 9 over 4x. Well, we can barely see what numbers those are. That didn't help a heck of a lot. There we go. If I multiply by 4, we get 20. If I divide by 9, we get 20 over 9 is equal to x. So this is the point 20 over 9, comma 0. Next up, we've got to write an equation through a point in parallel to this line here. Parallel means we've got to have the same slope. So I can take the slope is equal to 5 over 2. I've got a couple different options as far as how I might solve this. The easiest way is to use point slope. The standard way you guys tend to learn that is y minus y1 is equal to m times x minus x1. And if I plug things in, my point negative 2 comma 0 is going to be y minus 0 is equal to m is 5 over 2, and then x minus negative 2 for my x coordinate, and I'm done. I don't have to do anything else. I can stop there. The other way would be to write this as y equals mx plus b. So y equals 5 over 2x plus b. And if I plug in this point, 0 is equal to 5 over 2 times negative 2 for x plus b. We get 0 is equal to, those cancel with negative 5 plus b, which means b equals 5. My equation would be y equals 5 over 2x plus 5. Next up, we've got to write an equation for a line through 2 points. The first thing I notice is that I happen to know the y-intercept. So I don't have to use point slope. I can use y equals mx plus b very easily from this. I also know I need to find the slope. That's be negative 2 minus negative 5 over negative 3 minus 0.
Julia, have a quick getaway plan?
Ends up being positive 3 over negative 3, which is negative 1. So you end up with y equals negative x minus 5. Okay, in order to solve this equation, it's absolute value, so we've got to get the absolute value part by itself first. This is probably a really important thing here because the negative up front, I don't love that. First, I'm going to add 1 to both sides. We get negative absolute value of 3 plus n is equal to negative 5. I'm going to divide both sides by negative 1, and I get the absolute value of 3 plus n is equal to positive 5. Okay, now we're in a place that works. Absolute value has to have a positive answer. And now we can make our two equations. The first is 3 plus n is equal to 5. That makes this n is 2. And the second is going to be negative 3 plus negative n, I made both of those negative, is equal to positive 5. So only the stuff inside the absolute value was negative. Add 3 to both sides, and I get negative n is equal to 8, which means that n is equal to negative 8. Just to make sure these are not extraneous, I'm going to plug them back in. I'm going to choose the most simplified form that still had an absolute value. If n is 2, 3 plus 2 is 5. We're good. If n is negative 8, 3 plus negative 8 is negative 5. Absolute value makes that positive. Both of these work. They are not extraneous. To get credit for that on a spiral, please show me that you're plugging it in so that you can at least show that you're doing the math for that. You don't necessarily need to show me all the steps in the math. I do need to see that you're plugging this in. Another absolute value equation. I'm going to start by adding 4 to both sides to make this 20. And then divide both sides by 4 to get the absolute value of 2 plus 3x is equal to 5. Okay, let's break this into two equations. 2 plus 3x is equal to 5, and negative 2 minus 3x is equal to 5. These are my two equations that come from the absolute value equation. Minus 2 to both sides, I get 3x is equal to 3. If I divide both sides by 3, I get x is equal to 1. Okay, I'm going to add 2 to both sides, and I get negative 3x is equal to 7, which means x is equal to negative 7 over 3. Checking these two values out, I'm going to use the simplest absolute value equation that I still have. 2 plus 3 is 5. That works. We're going to have 2 plus 3 times negative 7 over 3. That's negative 7. 2 plus negative 7 is negative 5. The absolute value of negative 5 is 5, so that one works too. Nothing is extraneous. We have an absolute value inequality. This one's set up so all we have to do is basically make our two equations and go from there. So we get n over 4 is less than 1, and negative n over 4 is less than 1. If I multiply both sides by 4, we get n is less than 4. Here I'm going to multiply both sides by negative 4 to get rid of the negative in the same step. And when I do that, I get n is greater than negative 4. So we're looking at 4 and negative 4. If n is less than 4 and greater than negative 4, we're talking about the stuff in between these 2 points. As a rule of thumb, an absolute value less than a number produces an inside thing, and absolute value greater than is going to produce the outside part of this.